today's assignment, you are going to look at the sequence, and it is an arithmetic sequence, and find the rule. I know it doesn't say find the rule, but that is what it means. When you take the STAR test, you could possibly see a question that says, the first 5 terms in a pattern are shown below. If the pattern continues, which expression can be used to find the nth term? How do you do this problem? Well, they gave you the answer, the result, the dependent variables, the dependent values, the Y of the table. So now we need to find the X. And I'm going to zoom in so you can see what I'm doing. And so I'm going to leave a little spot there, and you'll see why in a moment. So this is X, and this was 1, 2, 3, 4. Okay, and it said first 5, and I left off 1. I'm just now noticing that. So when you come to class, this will be fixed. But let me go ahead and add another number since it's not there, because I did say first 5 terms and I only provided you with 4. Can anybody guess what that 5th term is supposed to be? Good job, 18. Okay, so now I need to find my pattern, and I'm going to start using a different word. I don't want to use the word pattern anymore. I want to use the word slope, because slope means pattern. And I'm not going to use starting point anymore. I'm going to use the word Y-intercept. So what is the pattern? What is the slope? Well, remember, you go here, and that moves by 3s, and it's going up, so the slope is 3. The pattern is 3. And now we want to do the Y-intercept, the starting point. Well, remember, this is when X equals 0. What is Y? So 0. And then if I'm at 6, what am I going to do? I have to go up 3 to get to these, and I'm going up 3 to get to 6. I started at 3. So the rule is 3x plus 3. This is my Y-intercept. This is my slope. This is my pattern. This is my start point. And I look for that answer here. Now the answer choices look really funny, funky, and weird, correct? Well, do you notice that there's an N here instead of an X? That is because if the pattern continues, which expression can be used to find the nth term? The nth term is why you see N here. What does nth term mean? In other words, what formula can I use to find any number in this sequence? Which means, what's the rule? In a nutshell. So I don't want the wording to make you feel like you don't know this, because you already do. It's really just finding the rule. So which answer choice looks like that? And it would be D. AN is the same thing as saying Y. XN is X, so 3x plus 3. Moving on to the next question. If the pattern continues, which expression can be used to find the nth term? And we have been given 5 terms in the pattern. We were given 4, so we need to get 1 more. Can you tell me what that term is going to be? Well, do you see what it's doing? It's going up by 90. So it would be, that's right, 370. So now, what do? We draw our table. Remember, these are the Y values. and up here would be the x values. So this is 1, 2, 3, 4, 5. And of course we need to know that's 0 because that would be our starting point, our y-intercept. So y equals box x plus box. The first one is slope. The second one is the y-intercept because we're not using pattern and starting point anymore. So the slope is from here to here, here to here, here to here, and that's going up by 90. The y-intercept is where it starts. So where does it start? At negative 80. If we're going to go down 90. And which answer choice looks like that? This one here. Because the AN is our y. And then the negative 80. The 90 is what the pattern was on our y, and the negative 80 is the starting point. Okay, so one more thing on this worksheet. I see A4, and I want to know what that means. That just means what is the fourth term. And there it is right there, 15. This one here says A3 equals 190. So what is A3? 190 is the third term. That's it. So when you come to class and you get this worksheet, surprise your teacher and go ahead and do number 1 and 2. That way you can start with 3 and 4 and move a little quicker during class time. Now after we finish that, we need to talk about the input and output machine. So I'm going to take example number 1. I'm going to use this here and input that into our input-output machine. So the first thing is to write down function. The function f of x, which means y, from number 1 was 3x plus 3. Now, I want to choose some numbers to use, okay? So, because it has to go into the function, and it's going to come out. So what numbers do you want to choose? Let's do, because I know you're going to do this in class, let me start with what we had on our table from question number 1. And we started with 0, we went to 1, 2. So let's do that. And this way we can kind of check this work to see if this is really correct. So let's do 0, 1, 2. And let's plug those numbers into this function. So how do you do that? Well, we use the table to help us. Okay? So these are our input values. Now, so I'm going to put x here because we know that's the independent values. We know that this is input. We also know that that's domain. We know that this here is going to be the y. So that is the dependent, the output, the range. And we just learned that this is also the same thing as f of x. Now, I'm going to use 0, 1, and 2 on my table. How do I put this into the function? Well, let's write the function here. When you put 0 into the function, into this input and output machine, this is what happens inside the machine. Wherever I see an x, I'm going to put 0. So when 0 goes into the function, what do I get? So I wrote 0 everywhere I saw an X. This says put 0 in the function. That's what that says. And I just did right here. That's all that means. So 3 times 0 is 0. Plus 3 is 3. Now what do we put in this last box? We're going to put our point, x, y. What is x? 0. What is 3? What is y? It's 3. So then you come over here and graph 0, 3. Now be careful. This means x equals 0 and y equals 3. So you have to graph both of those lines to get this point. Now some of you are thinking that this right here is 0, 3. Well, ask yourself a question. Is this the x equals 0 line? No, it's not, because it says x. The x equals 0 line is this one. And then y equals 3, that's a horizontal line. 1, 2, 3. So when I make those two lines, I create the point 0, 3. Okay, let's do number 1 and put it into the function. So f of 1 is how you say it. Now what does this mean? Put 1 into the function. That's what it means. The way you say it is f of 1, f of 0, f of x. What am I putting in place of the x? 1. What is 3 times 1? 3. This is multiplication because there is nothing between it. It's in parentheses. That tells me to multiply. So 3 times 1 is 3. Add 3 to it and you get 6. Now we write our point, 1, 6. So this means that x equals 1 and y equals 6. So if you graph those two lines, you should get the correct point. So x equals 1 is this. Y equals 6 is up here. And they will cross right there. And you can check it. Up, over 1, up 6. So that's the correct point. Now we do 2. Plug it into the function. That's what it means. Put 2 in the function. So 2 is going to go through my function machine, my input and output machine. And it's 3 times 2 plus 3 is 6 plus 3, which is 9. So the point is 2, 9. So I need to graph 2, 9. That's x equals 2, y equals 9. So x equals 2 is here. Y equals 9 is here. So there's my point. Now, what did the input and output machine do? Well, when I put 0, 1, and 2 into my function, out came 3, 6, and 9. Those were my output values. These values, that's my range. Those are my dependent values. These are my independent values. That's my domain. So my domain went into the function and out came the result, the dependent values. So if you notice, I have 3 points, but there's still more room on this graph to graph more points. So can you figure out what the other points are? Right now I have 0, 3, 1, 6, and 2, 9. Can you tell me what it would be at -1? Well, yes, you could simply put in -1 here into the function machine. 3 times -1 is -3. -3 plus 3 is 0. But you could also just count the pattern. If this is going 1, 2, 3 over 1, then this is just going to do the opposite. 1, 2, 3 over 1. Look at that. I still get the same answer whether I follow the pattern or I plug it into the function machine. So can you tell me what it would be at -2? So right here, could we follow the pattern and go down 1, 2, 3? Yes, we could. And just continue that pattern. Now I have completed and filled in as many points as possible, but I want to write down what those points are. So negative 2, negative 1, negative 2, negative 3 was negative 3. Negative 2, negative 3 was negative 6. It looked like I ran out of space, but negative 4 would have been negative 9. Now I'm going to use the hall pass. You should be using your ID to connect your points using a straight edge. And there you have your graph. Remember, this is a continuous function. How do we know it's a function? Because when we draw a vertical line through it, it only hits it once. So it is a function, and it's continuous. It's continuously going. There are no breaks in it. That's why the line connects all the dots. And this is the input and output machine.